Welcome to Programming with Python. This is the course introduction video where we will go through all the points that you need to know in order to get started with this course. First of all, this is a 10-credit course which introduces algorithms and basic programming concepts using Python as a language. And there are essentially three components of this course. We have online lectures, we have review sessions, and we have weekly lab classes. Concerning the time that is needed in order to get through this course, I would estimate that you will need at least 4 hours per week for self-study of the online lectures, plus another 4 hours for solving the exercises. If you are already familiar with Python, maybe you learned it in school previously, then this might be slightly less, but I think 8 hours per week are required, at least in the early weeks of the semester, if you have not done any programming before. It is very important to plan in sufficient self-study time for this course. This is not an easy course, which I would like to emphasize here. And note that there are no January exams. It's coursework only, and therefore all the learning will happen during the semester. So please make sure to reserve enough time for revision of the course material and also for solving the exercises. Here's some general information. My name is Stefan Güttel and I will be your lecturer for this course. All the materials and announcements are on the course webpage. Here's a link. You also find the same link on the Blackboard page. Okay, these all point to the same resource. The teaching times are as follows. I recommend that you spend Monday morning with the self-study of the online materials which are provided on the course webpage. Then on Monday between 3 and 4 p.m. we have an online review session where I will go through some of the exercises and also repeat some of the stuff that is contained in the lecture materials. And then there are 2 lab classes on Thursday. The first one is between 9 and 11 and the second one between 12 and 14. You only need to attend one of these 2 2-hour online lab classes each week. Please check your personal timetable in order to find out which of the 2 is for you. All the self-study materials, the lecture notes, are provided on the course website, and there is an interactive way to look at the video lectures. I just show you what this looks like. So here is the course website. You have all the important information about the course, and here you have week by week the course materials. For example, if we look in week number 1, the course introduction, and we view the core material, you have 3 different ways to view these. You can either just look at the HTML file. If you click on that, you have the materials in HTML format. This is quite good if you want to resize it. If you want to read it in a larger font size, you can freely do this using your browser. Alternatively, you can view the PDF version of the lecture notes. This is useful if you want to print it out or maybe annotate it on your tablet. And finally, these are the interactive video lectures. So if you click on video, what you will see is a small thing that I put together for you. So you have the videos on the left. Let me just stop this. You have here some timestamps. So if you want to learn, let's say, about inputs, you can click here. You will get the corresponding position in the lecture notes. And also, you have here a basic Python interpreter. Let me just get this nicely formatted. So you can actually type Python code on the right-hand side of this window. For example, here I have a print hello world program, and you can execute it. Right? So while reading the lecture notes, you can try out some of the things that we discuss immediately on the right-hand side of the browser. So hopefully you will find this useful for studying the lecture notes more interactively. If for some reason the video in these interactive lectures does not play, then that's likely because you do not have access to YouTube. In this case, there is an alternative version of this page on the website marked as Alt. Okay, so if you have problems with these interactive video lectures, then click on the link Alt. If you are new to programming, which I assume in this course, You will make a lot of mistakes initially, so-called bugs in your computer programs, and hence you will require a lot of feedback on your codes. We will not be able to give feedback on code via email for obvious reasons, like, for example, computer codes can contain computer viruses. We should never trust any computer codes that we receive via email. And also we want to give uniform help to all students. So please do not send me any Python codes via email. I will not be able to respond to these. However, we have really good feedback opportunities in the lab classes, where there are many helpers available. So please make good use of the lab classes, which take place on Thursdays. You have 2 hours every week to ask any questions you have on your computer programs. In addition, we provide support in the Blackboard forum or discussion board. So please look on the main page of the course on Blackboard and you will find a link to the Blackboard discussion board. And there you will be able to post questions and receive answers on your problems. So just to reiterate, we will give feedback on computer codes in the lab classes and in the Blackboard forum, but only there. It is not possible for us to give any feedback via email. The Blackboard forum, or discussion board as it is also called, is an easy way to discuss exercises and other questions relevant to the course. If you go to this forum, you will have the option to read all previous threads that people have posted. You can see the title and who posted a particular question, and you are also able to create new threads. So if there is a particular question that you cannot find the answer to, then you're very welcome to create a new thread. But please, before creating a new thread, please check whether someone else has already asked your question and it might already been answered previously. Now there's a small downside to Blackboard when it comes to posting code, which we will do a lot, I suppose. It's a little bit inconvenient, but it is possible to use. What I recommend if you want to create a thread that contains some code, first of all, always pick a meaningful subject to your particular question that you have. It will make it much easier for others to pick up your question and answer it. Okay, so that's the first point. You might, for example, refer to the number of a particular problem sheet or an exercise in the title. Secondly, when posting code, what I recommend doing is in the message box on Blackboard, first click the HTML button and you will see a new window opening up. Before you type anything else, I recommend to type the following HTML code. Okay, so you have brackets pre and then closing brackets pre. This stands for pre-formatted text. So everything you put in between these brackets will maintain its format in the post after you submit it. So here's an example. I have opening tag pre and closing tag pre, and in between I have copied and pasted some Python code, and I would then click on update and it will end up in my message box, and then I could ask or write some further information about my particular post. Let me show you a concrete example. I'm now on the Blackboard main page. There are two links. The first one is to the course materials and the second link is to the discussion forum. So I'll click here. And now I will create a new thread by clicking here. I have a particular problem, which is a program called Hello World. So I will ask, can someone suggest improvements to my code? Now, before typing anything here, as mentioned, I will first click on this small HTML button. A new window comes up. Just increase the size a little bit. Now I'm typing the HTML pre-formatted text tab like this, and then the closing tag like so, and then in between these two I can copy and paste my Python code. For example, if you are running the Spyder editor that we will introduce a little bit later, I can just copy and then paste the code to the corresponding window. Right, so I've now copied and pasted Python code here, and now I will click Update, and you should now see the code here in a nicely formatted manner. If you copy and paste code directly into this box, it looks like this. Everything ends up in a single line, and that's impossible to read. Right? That's why I recommend using this HTML button here and then the pre-HTML text, pre-formatted tag. And now you can add a bit of text here. So, can somebody please give suggestions as to how to improve my code below? And always remember, you're talking here to other people on the forum, so let's be polite. So after we have written our question here, maybe we thank them in advance, right? And I can now then I can then submit my Python code by clicking submit, and it should have now created a new thread in our discussion board, and hopefully someone else will pick it up and answer it. By the way, if you are a student and you have some suggestions on a particular problem, you want to answer some questions, you're very welcome to do so. Right? So everyone is invited to contribute to this discussion board, and if there are some strong Python programmers, please do not hesitate to answer questions as well. There are alternative ways to share Python codes. One of them is the codeshare.io webpage. So you can go to codeshare.io. You might want to create an account. I would recommend doing so. And this webpage just allows you to copy and paste some code and share it. So here is codeshare.io. I have already created an account. I can click on share code now. A new window comes up, and I can then copy and paste my Python code here and click on share. This will give me a link which I can then copy and paste to a friend. I can share it via a Zoom call or maybe on the Blackboard discussion board. The other person will then be able to see your code, and you can actually modify it both in real time. So both people can work on a code together, which is quite nice. Also, CodeShare actually allows you to have video chats, which can be quite useful in some cases as well. Now you might wonder, what about the assessment for this course? That's pretty straightforward. We will have 2 mini tests, one running from October 26th till October 30, and one running from November 16 till November 20, so 1 week for each. And each of these 2 mini tests will count 15% towards the overall course mark. There will be a larger coursework project starting on November 23 until the end of the semester, which will account for 70% of the overall mark. I will give more details on these assessments as we come closer to the date. Every week there are exercises that have to be completed before and during the lab classes. You find them on the course website. These exercises are extremely important to actually learn Python and to prepare for the assessments. So please make sure to attempt them. This brings us to the question of how do we actually learn coding? You can think of programming a little bit like learning a new language. Okay, and the only way to learn a language is to try, listen, and speak that language. Now we will cover both of these, listen and speaking, in this course. You will listen to computer codes by seeing other people coding. This is what the live coding sessions are for. And of course, I will also provide you with example solutions to all the exercises that you can study independently. But then, most importantly, you should always attempt writing your own computer codes. That is the equivalent to speaking a language. Even if it is with errors in the beginning and mistakes, you have to learn from your mistakes. And the only way to do so is to actually attempt writing your own Python codes. Now, in order to do this practically on your own computers, we will use a so-called integrated development environment called Spyder, which is contained in the so-called Anaconda distribution. Now let me unpack this a little bit. What do these terms actually mean? First of all, what is Python actually? Well, Python turns out to be a computer programming language. In other words, this is a language that you can use to give instructions to your computer. Okay, so we just use it to instruct our computer what to do. You can think of, if you want some analogy, you can think of your computer as a good friend who follows your instructions, and Python would be the language that you communicate with him or her, right? There are, of course, various ways of communication. Just as in the real world, you can communicate via phone, email, chat, and so on, some of which are more interactive than others. For example, chatting is more interactive than writing a letter, for example. And similarly, there are various ways to use the Python programming language. So a bit of terminology. Python itself is just one of many different programming languages. You can give instructions to the computer in a multitude of different programming languages, and it is the language that we will use to write computer programs, but there are many others. IPython is an interactive Python interpreter. So that's a computer application that takes your Python programs written in the Python programming language, and executes them. Jupyter is yet another way to run Python programs. It's a web application that allows us to run IPython in the browser. Then there is Spyder. Spyder is an integrated development environment. That's a computer application that includes IPython and a text editor for writing and debugging programs, and many other things. We will have a closer look at Spyder in a minute. There's Jupyter Lab, which is a more fancy version of Jupyter Notebooks. It's also an IDE. Then there is the concept of modules. For example, pyplot is a module that provides visualization tools. There is NumPy, which is a library. A library is generally a collection of modules, data types, and so on. In the case of NumPy, it provides numerical arrays and mathematical functions. And then we have Anaconda, which is a Python distribution. A distribution is essentially a big file, a single download that you get, for example, from the web, which conveniently packages all of the above into one product. Right? So when we download and install Anaconda on our computer, we get all of these things at once. So how do we get Anaconda from the web? Well, we just have to go to this web page here, www.anaconda.com/products/individual. And then on this web page, scroll down to the 64-bit graphical installer. Now there are 3 different versions available. One is for Windows, then we have for Mac OS and for Linux. And depending on the software that you're using, the operating system that you're using on your computer, please select the 64-bit graphical installer. It should then start with the download of an exe file in the case of a Windows machine, or a PKG file in the case of a Mac. And in your browser, you will find this exe file down here in the footnote. Once the Anaconda program has been downloaded, you can just double click on it in order to start the installation, and you will see several windows in the installer that you just have to confirm. I recommend that you keep the standard sessions throughout the installation. So let me show you an example. I am now here on the web page that I indicated. This is the Anaconda web page. I have found the Windows installer. I just click here and the download will start. There is another window opening which we can ignore. We just have to wait until the Anaconda exe file has been downloaded. It's about 460 megabytes, so this will take about 6 minutes on my connection. Right, my download has completed, and I can now click on the installer. There we go. And now, as mentioned before, I recommend just clicking through this, agreeing the license agreement, install for just me, that's fine. I will keep all these settings as they are. No need to change anything. And it's now installing Anaconda 3 on my computer. Now, after the Anaconda installation is complete, which takes quite a while, you will be able to start up Spyder, the integrated development environment we will be using, by just typing Spyder in the Windows search bar, or alternatively, if you use a Mac, you will find Spyder somewhere in the navigator, probably under the Anaconda distribution. So on Windows, just type Spyder in the search bar and you will find Spyder Anaconda 3 app coming up here. So just click on this. When you click on that, Windows might ask you, when you do this for the first time, whether you want to accept firewall access, and you can happily click OK there. After Spyder has been started, you will see a program that looks like this. It looks a little bit busy when you see it for the first time, but really the most important parts are the editor, which is shown here. This is where we will write our Python programs, and then the execution area down here, which is the so-called IPython console, which takes our inputs and outputs of programs. And then you have a lot of menu items up here. You can just click through them and see what's contained in there. Now, just to write our first Python program, as a test, I recommend you delete everything that is in the editor window and you type something like this: print brackets, then quotation marks, hello world, quotation marks, brackets. Okay, this is a valid line of Python code. And then you will save this file somewhere on your computer. And this is very important. Throughout this course, you will be able to reuse all the Python codes that you have written. And I strongly recommend that from the very first Python program you write, you try to be very organized about it. Okay. So what I recommend doing is you go to, in Spyder, you go to File, then Save As. And before you do anything else, you create a new folder on your computer, for example, on your desktop, and you might call this folder My Python Materials. Okay. So make it a habit to save all your Python programs in this single folder. Otherwise, after week 3 or 4 of the semester, it will be a complete mess and you will not be able to find any of your previously written programs. Okay. Maybe it makes sense to have subfolders as well, maybe a week 1 subfolder, week 2 subfolder, so everything is ordered by the week of the lecture. So once you have done this, you have created your folder, you can give a name to your program, and in this case I will just call it hello.py. py is the file extension that indicates that we have a Python program here, and then you simply hit save. This should save the Python program, the single line Python program that we have just written, onto your computer. Now, in order to run this code, in order to execute it, we'll have to do the following. We'll click on Run up here. A drop-down menu will open in which you will find another entry for Run. So you click on this, or alternatively, you can hit the F5 key on your keyboard if you have one. Okay, so this will be a shortcut for running a program. Before it actually runs, a window like this will open. This always happens the first time you execute a program in Spyder. And here I recommend to use the following setting. Under Console, select Execute in a dedicated console. Under General Setting, checkmark Remove all variables before execution, and the rest can just stay as it is. And then you finally hit Run down here. If everything went well, then the Run dialog should close and you should see down here in the IPython console the text "Hello World" printed out. And of course, this is exactly what our Python program on the left has instructed the interpreter to do. Just print out the string "Hello World," and that's what we see here. And generally, this is how we will use Spyder throughout the course. On the left, we will write our Python programs. We will then execute them, run them. By the way, you can also do this with this green arrow button up here, and you will see all the outputs of the programs down here in the IPython console. Now, because this is so important, let me just go through this whole procedure one more time, now directly on my computer. So first of all, we start up Spyder by typing Spyder in the search bar. Okay, this should open the Spyder IDE. Dependent on your computer, it might take a few seconds to actually start up. Here we go. Now this is an empty Python program that is already prepared by Spyder. As we mentioned before, we can just delete this and type print brackets. I get some recommendation for updates. I will ignore this for the moment. You might not find this. And then I'll type here "Hello World." And then I will go to File, Save As. I will select the Python course materials folder on my desktop. I will call this Hello2 because I previously created a hello.py program. I will save it. And now you can see above the editor that I have stored this file in the location Dropbox desktop, my Python course materials, hello2.py. And now I go to run. This dialog opens up where I select execute in a dedicated console and remove all variables before execution. And then I hit run down there. Python will now connect to a kernel. So the kernel is the program running on my computer that can actually understand Python and execute it. And after this is completed, it will indeed print out "Hello World" to the console. As a first small assignment for this week, I would recommend you to go to the course webpage and download the 01guess.py file, which is available there. Move it into a week 1 folder on your desktop or wherever you want to store your files. Open it in Spyder, run it, and then play with it. So I'll go through these steps now directly in Spyder for you to see how to do that. I will first go to the course webpage. Here it is. And on this course webpage, you will find a link to the so-called guessing game. On Windows, I'll just right click and then save link as. And I will now select the week 1 folder in my Python folder, which I have created on a desktop, and just save the file in that folder. I have previously already downloaded this file, so I'll just do it one more time. It should now be here. And now I can go to Spyder, File, Open, select my week 1 subfolder and select 01guess.py. This will open this program that you can see here. You can scroll down, have a quick look, and I'm now going to run it. So I click on Run File. Again, Spyder will try to connect to a Python kernel in order to run our code. And then you see here that we are asked to guess a number between 1 and 100, and I'm now able to type in some guesses. So what about 27? Well, that doesn't seem to be the correct number. I should try a smaller one. Let's see, 13, try a slightly larger number, maybe 20, and so on, right? 25. Okay, I'm not going to continue here, but you get the idea of this game. You basically have to guess a number by just typing in guesses one after the other, and the computer will reply with a hint, so the number is too small or too large. Now, why is this interesting? This is interesting because this is a piece of computer code that is not very long. So here's the full program for that. And even though you haven't learned Python potentially, you might be able to make sense of this computer program by just looking at it. So the assignment for this week will be to download the code on your computer, get it opened in Spyder, get it to run, to execute, and then have a look through this program and see if you can make any sense of it. You might not be able to make any sense of it, and that's completely fine. You will be able to do so by the end of this course, but maybe actually if you look at it from a very top level view, potentially some of the things make sense. By the way, if you're running a Python program and you want to stop, there is this red button here, stop the current command, which you can click, and it will stop the execution of your Python program. You can then restart again by clicking on the green arrow symbol up here. Also, feel free to modify this guessing game. Change the code and see what happens. Generally, I would say never be afraid to modify computer code. It is quite likely that you will break it in the first instance, but you won't break your computer. It's just the code that won't work anymore. And the best way to learn programming is to try to fix the code again. So once an error has been introduced, try to fix it. And if it doesn't work, continue trying to fix it, right, until it works eventually. That's unfortunately the only way to become a good programmer, by trial and error. There's also a link here on these slides which you can click referring to this guessing game. That's an interesting YouTube video where someone actually talks you through the development of this program step by step. Finally, let me say a few words about the case that the Anaconda installation fails on your computer for one reason or another. Due to the large capacity, large number of students on this course, more than 250, we are not able to provide individual IT support. Okay. We very much hope that Anaconda installation just goes through, and it's very rarely the case that this fails. So hopefully everything goes fine. In case it doesn't, my first recommendation would be to try to uninstall it and reinstall again. Sometimes this fixes the issue. And if you have another computer available or another notebook, maybe try install it on another machine. That might also fix the issue. If all of this fails, there are very convenient online IDE alternatives available. One of them, which I like a lot and actually use more often than Anaconda itself, is called repl.it. Okay, the URL is repl.it. And this is a convenient browser-based Python editor, which also allows us to run Python programs. It will in fact be sufficient for almost all purposes in this course. So let me quickly show you how repl.it looks like. I'm going to the repl.it web page. I have actually created an account there, and I recommend you do the same, because then all your Python programs will be stored. Otherwise they get lost after you typed in your Python program. You can then click on New REPL, then select a programming language. Repl.it actually supports many different programming languages, not just Python, but we are interested in Python. We can also select a Python. We are also asked to type in a name for our program. So I will call it Hello World 2, let's say, and then create REPL. And this opens up an editor, which is this part here, and also an interpreter for our Python codes. So just as in Spyder, we can now do something like print hello world, and then hit run, and it will also outprint hello world on the console, just as was the case in Spyder. So this is a very viable alternative, and you might even prefer using this because it runs in the browser and you can access it from anywhere. You can even do Python coding on your mobile phone if you wanted to. Finally, here is a short summary of what we have discussed in this course introduction video. By now you should have a good idea about the format of the course. There are self-study lectures with the lecture materials being available on the course website. We have review sessions and we have lab classes. I have highlighted that it is very important to schedule your own learning in order to keep up with the material. Please make sure that by the end of each week you have covered all the materials and exercises that are posted for this corresponding week on the course web page. You can get feedback in the lab classes and via the Blackboard forum, so please familiarize yourself with the Blackboard forum, in particular how to post questions there. And most importantly, you should install Anaconda on your own computer. Please follow the instructions in this video. And also I pointed out that there is a first assignment, this guessing game, which you can download from the course website and run on your computer and try to make sense of. I have also mentioned other tools for sharing code like codeshare.io and repl.it, which is an online Python editor that you can use as an alternative to Anaconda. This is the end of this video. I'm very much looking forward to doing this course with you. I hope you will become very good programmers by the end of this course, and also, most importantly, that you have some fun learning something new. So I'm looking forward to seeing you to the first review session on Monday afternoon. Please now have a look at the week 1 lecture, which is posted on the course website. Thank you and see you soon.